Okay, topic number 1, review of fractions, decimals, and definitions. Let's jump right in. Question number 1, what is the decimal equivalent of 7/8? All right, 7/8, you can think of it as, well, let's think of it as a circle, and we have eighths, right? So we have 1, 2, 3, 4, 5, 6, 7, 7 out of 8, so we have 7/8. That's another way to think of 7/8, where you have a little opening there. That's the eighth. You can also think of it, and if you've never thought about it this way before, you should start 7 divided by 8, because 7/8 is the same as 7 divided by 8. It's just another way of thinking of the same expression, or the same fraction. Fractions can equal division problems, and that's the key to going from a fraction to a decimal equivalent. All right, so let's do that. Let's do 7 divided by 8. 8 goes into 7 0 times. Bring down the decimal point, bring up the decimal point, bring down a 0. 8 goes into 70 8 times. 8 times 8 is 64. Use subtraction, get a 6, bring down another 0. 8 goes into 60 how many times? Let's try 7. 7 times 8 is 56. Use subtraction, get a 4, bring down another 0. Oh my goodness. Now 8 goes into 40 how many times? 5 times. 5 times 8 is 40. We have 0, and we are good to go. That's 0.875. It's the same as 7/8, and that's our answer, C. Okay, question 2. Doug earns $10.50 per hour working at a restaurant. On Friday, he spent 1 3/4 hours cleaning, 2 1/3 hours doing paperwork, and 1 5/12 hours serving customers. What were Doug's earnings? Okay, so he earns this much per hour, and he worked this amount of time, that amount of time, and that amount of time. All right, people think of it as hours and minutes, not 1 hour and 5/12 of an hour, but it's a math problem. You kind of got to deal with what they give you. All right, so we want to find out how much money he's going to make, and to do that, we need to know how many hours total he worked, because then he will have earned $10.50 per 1 hour, and we can set up a proportion and multiply that by the amount of hours he worked, and that will give us our answer. Okay, so we have 1 3/4 plus 2 1/3 plus 1 5/12. Where do we get these numbers from? Well, they're from the problem, right? 1 3/4, 2 1/3, 1 5/12. Okay, so far so good. What are we going to do with these numbers? Well, we can't really add them together without a common denominator, right? We remember this from 5th grade and from 6th grade. So let's get a common denominator. And we're going to see right away that 12 will work. So 4 times 3 gets you 12. So do the same, multiply it by the same number. Whenever you do to the bottom, you got to do the same to the top. You get 9. 3 times 4 gets me 12, so whatever you do to the bottom, do the same thing to the top, and you're going to get 4, because 1 times 4 is 4. 12 times 1 equals 12, so just multiply it by 1, and you get 5. All right, there we go. Well, we couldn't add these numerators together because they had different denominators. Now we have common denominators, and we should be in good shape. We have 1 9/12 plus 2 4/12 plus 1 5/12. What does that get? 9 plus 4 plus 5. If we add it up, we get 18. Remember, this stays the same. 12ths. That's how adding fractions works, or adding mixed numbers work. We get 1 plus 2 plus 1 gets you 4. So now we have 4 18/12. The problem is that this is now an improper fraction mixed with a mixed number. My goodness. 4 18/12 doesn't make any sense. The numerator has got to be smaller than the denominator in a common mixed number, right? Otherwise, this is an improper fraction. We got to deal with it, right? So what do we have? We have 4 18/12, which is, if you have a circle, that would be 12/12, and we have 6 left over because 12 plus 6 is 18. Another way to think of this is if we divide the numerator and the denominator both by 6, we'd have 4 3/2, right? 4 3/2. because 18 divided by 6 is 3, and 12 divided by 6 is 2, and 3 halves is like this. Here we have 2 halves, and here we have 1 half. So what is that? Well, if you think about it, that's just going to equal, this is a whole, and this is a half. So 4 and 3 halves, this part equals 1 and 1 half. So let's keep the 4, and then we're going to add the 1 and add the 1 half. That's good legal math, right? This expression here, 3 halves, is added to the 4, because we have 4, then we have 3 halves more. And 3 halves is the same as 1 whole and 1 half. So that would equal 4 plus 1 plus 1 half, which equals 5.5. And we're good to go. Now we have 5.5 up here. So with 5.5, so we worked 5.5 total hours. That's 5.5 total hours of working. And we go up here and we say, okay, you earn $10.50 per 1 hour. How much money are you going to earn if you work 5.5 hours? And you're like, well, that's kind of tough to do because I have decimal here and a fraction here, or I should say a mixed number here. So I'm just going to write 5.5 a little differently. I'm going to write 5.5 as 5.5. That's good legal math, right? Because 5 and 0.5 equals 5.5. I think that's good legal math. I think we all get it. And instead of dealing with the mixed numbers and the fractions, we can just have 5.5 there. Now all we have to do is cross multiply and divide. So cross multiplying would be 10.5 times 5.5, and you cross multiply and divide, right? Divided by 1. Plug that into your calculator, and what you'll get is 57.75. 57.75, and that will be your answer. Okay, question 3. Salid bought 35 feet of window trim at a hardware store. The trim cost $1.75 per foot, including sales tax. If Salid paid with a $100 bill, how much change should he have received? Okay, so we have dollars per foot. $1.75 per 1 foot equals how much per 35 feet? That's all we have to do. We know that $1.75 per foot, and we bought 35 feet. So let's use our cross multiplication skills again. 1.75 times 35, because you cross multiply. Then you divided by 1. Plug that into your calculator. What do you get? You get 61.25. Is that your answer? No! You got to read the whole question. If Salid paid with a $100 bill, how much change should he have received? Well, if he paid with a $100 bill, well, let's write it down here. I paid with a $100 bill. If he paid with a $100 bill, it'd be 100 minus what he paid for, minus 61.25. Plug that in your calculator, do it out. You get 38.75. If you do it out, you do 100, line up those decimal points, and 100 equals 100.00. Line up those decimal points when you subtract, and you've got to regroup and regroup and regroup and regroup. Got to do a lot of regrouping, right? So this, in order to make this 0 a 10, this 0 a 9, this 0 a 9, and this 10, 1, 0, a 9. And you have 10 minus 5, 5, 9 minus 2, 7, 9 minus 1, 8, and 9 minus 6, 3. 38.75. Okay, question number 4. The table shows prices for shoe rental, games, and snacks at a bowling alley. Look at this table, it's amazing. You get all these different prices for different things. Your questions then says, Gina rented shoes, bowled 3 games, and bought 1 order of nachos. She used a coupon for 1.5 off the price of her bowling games. What was Gina's total cost before tax was added? All right, so what do we have? What do we have? We have shoes plus 3 games plus nachos equals total cost, right? Because we have rented shoes, bowled 3 games, and bought 1 order of nachos. All right, so we have shoes plus 3 games plus nachos equals total cost. What do we know right off the bat? Shoe rental, $2.75. Games, well, 3 games is tough. Let's skip that for now. Nachos, $1.75. Alright, so all we gotta do is get the games, add it all together, and we'll get our total cost. Okay, so what about the games? We know that one game costs $2.50, and she bowled 3 games. So let's just do a little cross multiplication. 3 times $2.50. Did I say $1.50 before? Each game costs $2.50, right? Because that's in our chart. Each game costs $2.50. And we bowled 3 games, so $2.50 times 3 divided by 1, cross multiply and divide, gets you $7.50. $7.50. But then it goes with the half off coupon, right? Oh my goodness. Never can be simple. We have a half off coupon. So we have $7.50 here. I'll just write 7.5. And normally costs 7.5, but now as this little tape diagram set shows, it's going to cost 1/2 of 0.75. So we can do that as 7.5 times 1/2, or we can do that as 7.5 times 0.5, right? Because that makes sense. This is the same thing. Multiplying by half and multiplying by 0.5 is the same thing, because 1/2 equals 0.5. You know, you think about it, if we do this, if we do 7.5 over 1, because anything divided by 1 is that same number, times 1/2, that will equal, if we multiply the numerators and the denominators, 7.5 divided by 2. So 7.5 times 1/2 is the same as 7.5 divided by 2. It's the same as 7.5 times 0.05. Any way you do it, you're all going to get the same number. You're all going to get the same number, which is 3.75. 3.75. That's 1/2 of 7.5. 3.75. Okay, so we have all our numbers. 275, 375, and 175. Let's add them all together. We have 275, that's 375, plus 175. 5 plus 5 plus 5 is 15. Carry the 1. That's 1 plus 7 plus 7 plus 7 is 22. Carry the 2. 4, 5, 6, 7, 8. Bring down the decimal point. 825 is going to be our answer. Our answer is going to be 825. All right, on to question 5. A pile of newspapers in Miss McGrath's art class was 17 3/4 inches high each consecutive week for the next 5 weeks. The height of the pile of newspapers increased by 8 7/12 inches. What was the height in inches of the pile after 3 weeks? So what do we have here? What do we have? We have a pile of newspapers that starts at 17 3/4 inches high. Then it gets 8 7/12 inches more high for the next 1, 2, 3, 4, 5 weeks, right? Because it says for the next 5 weeks, the height of the pile of newspapers increased by this amount. What was the height in inches of the pile after 3 weeks? So my goodness, it's a curveball. We get information we don't need. We get the height of the original pile, 17 3/4. Then we get after 1 week, after 2 weeks, after 3 weeks, after 4 weeks, after 5 weeks. But we're told we don't care about weeks 4 and 5. We want to know how high it was only after week 3. Why are they telling us information we don't need? To be tricky. But we caught their trick, and we're going to get the right answer. Okay, so let's think of it this way. We have 17 3/4 plus 8 7/12 3 times, right? And you can think of this as 8 7/12 times 3 if you want, or you can just add it like I'm going to do. First, if we're going to add it all up, we know that we need a common denominator because we cannot add fourths and twelfths, but 4 times 3 is 12, and whatever you do to the bottom, do the same thing to the top. 3 times 3 is 9, so we have 17 3/4 becomes 17 9/12. 17 9/12. Again, you could just multiply 8 7/12 by 3, and then add that to 17 3/4. But to really hammer home how to add numbers, had to add mixed numbers and then convert that mixed number from a mixed number with an improper fraction to a mixed number without an improper fraction. I'm going to do it this way. Okay, 17 and 9/12 plus 8 and 7/12, 7/12, and 7/12. We add 9 plus 7 plus 7 plus 7, and we get, let's just do it out here, 9 plus 7 plus 7 plus 7, and we get 30. So that's going to be 30. What goes in the denominator? You should know this. The 12 stays. So that's 30 twelfths. And 17 plus 8 plus 8 plus 8 is going to give us 41. It's going to give us 41. Okay, so we have 41 and 30 twelfths. 41 and 30 twelfths. What are we to make of 30 twelfths? What are we to make of 30 twelfths, right? That doesn't make any sense. We're used to seeing a mixed number like this with a proper fraction where the numerator is less than the denominator. But now we have a mixed number and an improper fraction all mixed together. Well, you can think of 30 twelfths like this. 30 twelfths equals 12 twelfths plus 12 twelfths plus 6 twelfths, right? Because, 12 twelfths is 1, 12 twelfths is 1, and 6 twelfths is 1/2. Or you could divide your numerator and your denominator both by 6, and you'll get 5 halves. And you can think of 5 halves as 1, 2, 3, 4, 5. And that's 2 halves plus 2 halves plus 1/2. And if you do it like that, I think it's fairly clear to see that these two here are each 1. So we have 1 plus 1 plus 1/2. Or this will all equal 2 and 1/2. Just like this will all equal here the same, 2 and 1/2. We have 1 whole plus 1 whole is 2 wholes and a half. 1 whole plus 1 whole is 2 wholes plus a half. So we have 40 and 30 twelfths, 41 and 30 twelfths, and that's going to equal 41 plus 2 and a half, which equals 43 and a half. 43 and a half. Right? Because you have 41, and then you add the 2 wholes to get to 43, and then you have that last half. So how tall is this whole thing? For the after 3 weeks, it's going to be 43 and 1/2. On to question 6. Question 6 is a good chance for us to review our conversion of mixed numbers to decimals and to solve problems different ways. So that's exactly what we're going to do. Last week, Rachel power walked. Oh, good for you, power walking 2 3/5 miles per day on each of the 7 days. During the same week, she also jogged. My goodness, how awesome. 5 3/4 miles per day on 4 days. Okay, so you have 7 days in a week. Each one of those days, you have 2 3/5 power walking, and on each one of those days you have 5, or no, only on 4 of those days you have 5 3/4 miles jogged. What was the total amount of miles Rachel power walked and jogged last week? Okay, so let's start off with this 2 3/5. Let's unpack that number, because eventually we're going to have to multiply that by 7, right? And it's hard to multiply 2 3/5 by 7 right off the bat. So let's unpack it. And we can say 2 3/5 can be thought of as 2 plus 3/5. And 3/5 is the same as 6/10, because, 3 times 2 is 6, and 5 times 2 is 10. So you can think of 6/10 as 0.6, because that's 6/10. So you can think of 2 3/5 as 2.6. Or you can just divide 3 divided by 5. We did question number 1 where we went over that this is just another way of thinking of a division problem. So if you do 3 divided by 5, you can go straight to here, get that as 0.6, keep the 2, and have that be 2.6. Or you can say this is 2 3/5. Well, this is 5/5, this is 5/5, and this is 3/5, right? Because you have 1, 2, 3 out of a possible 5. If you add 5 plus 5 plus 3, you get 13/5. And if you want to do that with the algorithm, which is like a fancy way of saying formula. You can do 5 times 2. So you do 5 times 2, the denominator multiplied by the number, the whole number. 5 times 2 is 10, plus 3 is 13. So it's 5 times 2 is 10, plus 3. So multiplication going this way, addition going that way. You multiply, and then you add. So 5 times 2 is 10, plus 3 is 13, and you get 13/5. So I'm going to say, okay, I know this is 2 3/5 here, but I'm going to think of it as 2.6 or 13/5. I like decimals more than fractions, so I would be more inclined to think of this as 2.6, but, you know, let's think of it as 13/5 just for completeness. Okay, now let's go on to 5 3/4. 5 3/4. What are we going to make of that? Well, when you say 5 3/4, you can think of quarters, and there's 4 quarters in a dollar, so you're pretty sure it's going to be 5.75. But how do we really get there? Okay, you can think of 5 3/4. That's 5 plus 3/4. 3 times 25 gets you 75, and 4 times 25 gets you 100, and 5 plus 75 hundredths equals 5 75 hundredths. So you can just think of it as 75 over 100 is 75 hundredths, or you can do, and this is how I would do it, just think of this number, this fraction over here, 3/4, as 3 divided by 4 equals 0.75. Keep your whole number the same, and boom, there you go. 5 3/4 equals 5.75. Also, if you really wanted to do it, you could think of 5 3/4 says, well, you have, you know, this is 1, this is 2, this is 3, this is 4, this is 5, and then 3/4, right? So 4 quarters plus 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 3/4 equals 23, because 4 plus 4 plus 4 plus 4 plus 4 is 20, plus 3 is 23, and the denominator stays 4. Again, if you want to run the algorithm, it's multiplication going that way, so multiplication going that way, 5 times 4 is 20. Hey, that looks familiar, right? Because 4 plus 4 plus 4 plus 4 plus 4, 4 added 5 times is 20, plus 3, oh, hey. That kind of makes sense, right? Plus 3 is 23. You get it? The algorithm is multiplication that way, addition going that way, which makes sense because you have 4 quarters plus 4 quarters plus 4 quarters plus 4 quarters plus 4 quarters. How many 4 quarters do you have? You have it 5 times. You have it 5 times, 5 wholes. 4 times that is 20 plus 3 plus the other one gets you 23/4. Okay, so we have 5 3/4, and I'm going to think of that as either 5.75 or 23/4, and I'm really more inclined to do 5.75. All right, now we have to put those numbers to work, right? We know that we've done 2.6 miles 7 days a week. So this is us walking, right? 2.6 miles 7 days a week. Now let's just do some cross multiplication and division. 2.6 times 7 divided by 1. We can do that. That will be 18.2. Plug that in your calculator, do it out longhand. You're going to get 18.2. If you want to do it out longhand, we can just do it out really quickly. We could be like 2.6 times 7. 7 times 6 is 42. Carry the 4. 7 times 2 is 14 plus 4 is 18. How many decimal points? 1. 1 decimal point. There we go. All right. Is that what we're going to get if we do it the other way? Well, think of it this way. We have same deal of cross multiplication and division, right? We have 13/5 times 7. We can think of that as 7/1 divided by 1. And that, if we plug it into our calculator, 13 times 7 divided by 5, then divided by 1 again. And if we do it all out, we're going to get the same number, 18.2. All right, so we're good to go on the walking. We're good to go on the walking. We have 18.2 miles walked. For the jogging, that's 5.75 4 times, right? Because we only did this 4 days during the week. So how much do we get? Do another little cross multiplication and division. We have 5.75 times 4 divided by 1. What does that get us? If we plug it into our calculator, that gets us 23. If we want to do it out, we get 5.75 times 4. 5 times 4 is 20. So that'll be okay. 20, carry the 2. 4 times 7 is 28, plus 2 is 30. Carry the 3. 4 times 5 is 20, plus 3 is 23. How many decimal places? 2. 1, 2. So 1, 2. There we go, 23. We're good to go. If we do it out here, same deal with the fractions, with the improper fraction. Just cross multiply and divide. 23 over 4 times 4, which is the same as times 4 over 1 divided by 1. Well, hey, look at those cancel out. We're just going to get 23. Same number. All right, what do we have? We have 23 plus 18 over 2. Or 18 over 2 plus 23. So come back here. And this would all be work you'd want to show. This would all be work you'd want to show. And for the final answer, it's 18.2 plus 23. Get you 41.2 miles. All right, question 7. Question 7. Convert 3/11ths to a decimal equivalent using long division. Okay, we've been over this. 3 over 11 equals 3 divided by 11. You gotta know it. If you never thought of fractions as division expressions before, well, it's a good time to start. 3/11ths equals 3 divided by 11. All right, let's do it. 3 divided by 11. How many times is 11 going to 3? 0. Decimal point. Bring the 0 down. Or just bring a 0 over. Because 3.0 is the same as 3.0 million is the same as 3 million. $3.00 is the same as $3. The 0.0 isn't going to change what 3 equals, so 0.0 is fine. It just allows us to do 30 divided by 11 now with the decimal point up here. So how many times is 11 going to 30? Well, only be 2. 2 times 11 is 22. Subtraction, 8. Then you got to drop a 0, bring it down. 80. How many times does 11 go into 80? 7. 7 times 11 is 77. Do a little subtraction. Bring another 0 down. 30. Well, that looks familiar. How many times does 11 go into 30? 2. Well, 2 times 11, I think I've done this before, is 22. Do subtractions, 8. Bring another 0 down. 80. How many times does 11 go into 80? Well, that's 7. Wait, 7 times 11 is 77. That's 3. Bring another 0 down. Well, I mean, I could keep going, but I just know I'm going to get 0.27272727 repeated forever. So there I go. I don't have to do any more. I can understand the pattern here. And that pattern can be represented by a little line over the 2 and the 7. And that's my final answer.